differential equations. So in this lesson we're going to look at, we're going to be finding both the general and particular solutions to differential equations. So how to find a general solution to a differential equation of this type where I have a slope in two variables x and y. What we're going to want to do is we want to do what's called separating the two variables algebraically. So if I have this thing and look at it this way, we have y prime, which is a slope in two variables. We need to separate the y function from the x function. Okay? And we're going to separate those out using parentheses. We're going to separate them out so we can see them clearly. And then we're going to move the y to one side. Since it's represented as a product here, we're going to divide by the y stuff and get all the y's on one side and all the x's on the other side. Okay, this is the most important part of this. If you don't get this right, they will not grade anything else. So you have to have this correct. Once we have that separated out, we're going to find the antiderivative of each side. Sometimes you'll have to use substitution, sometimes you'll have to use other things, so we want to make sure we have our rules down. And once I've found the antiderivative of both sides, remember, because we have no limits, don't forget to put a plus c on it. We're going to need to solve for y. Okay, and so that's what we're going to do. We're going to separate the variables, find the antiderivative of both sides, don't forget plus c, and solve for y. Okay, let's look at an example and see how this works. Let's find the general solution of this one right here. Okay, so we look at this and we can see clearly that we have two functions, a y function and an x function. I recommend highly that you put them in parentheses to begin with so you can see them separately and know what you're going to do with it. We need to separate them out, so we're going to do basically cross multiplication and all that kind of stuff, and we're going to divide by the y and also multiply by dx, giving us 1 over y dy is the sine of x dx. So there's the y function, there's the x function. Okay, so we have separated them out. I want you to do that, and then I want you to do it this way. Please write it out as a separate line. Just get used to this. And at that point, if there was constants, you could have moved them out to the front and all that stuff as we did along. We're going to integrate both sides or find the antiderivative of both sides. This right here we know is the natural log of the absolute value of y. And then over here, we get negative cosine of x and then plus a constant. So we need to solve this for y. And since this is a log that's been isolated, we can exponentiate both sides and we end up getting the absolute value of y equals e to the negative cosine of x plus a constant up here in the exponent. I'm going to show you a little thing about this, what this means, so you can see how it happens and how you get certain answers for this. And then we're going to get rid of the absolute value. So first things first, this thing right here, because this is a plus, I can do exponent rules, and I can separate this out. So the absolute value of y is equal to e to the negative cosine of x times e to the c. Because same basis, you add the exponents. That's what we had. Well, e to the c is just a number, so that's a new constant. And so now I have the absolute value of y equals a new constant times e to the negative cosine of x. So that takes care of that plus sign thing that's up in here. If it helps us out, that's what we do. The next thing is this. How do I deal with the absolute value? Since this value in here, y, can either be a positive number or a negative number, this is a plus or minus this value here. So we have a plus or minus over there. We don't know which one it is. Now there'll be ways we're going to find it later, but for right now we don't know what it is, but they are there. This could be a plus or a minus, and what will happen is they will just get absorbed into the c, and so a lot of times you'll see this thing here as just simply being y equals a new c, because c plus or minus right here, e to the negative cosine of x, and that's usually what they call as the answer. I think for our purposes in here, we're going to want to just leave it like this for now. Okay? If on the AP exam they have an answer choice or a multiple choice and they have just a C in this, not the plus or minus, that means they absorbed it into it, and you can do the same thing too. Okay? So, let's look at the next one. Let's solve this one. So again, what is the y, what is the x? Usually what you want the y to be is you want to just take just the y stuff. Don't take constants with it or anything like that if you can avoid it. And here I can avoid it. I can look at this problem as 3x squared plus 2, over 5. I can take that 5 with this x part, and then in the y part I can just simply leave it as 1 over cosine of y. Like that. That's the best way to do it. Don't take the 5 with the cosine. Separate it out if it's possible. If it's not possible, then you got to take it with it, but this was possible. There's my x, there's my y. We need to get the y on the other side. So in this case, I'm going to have to multiply by the cosine of y on both sides. This would be 3/5 x squared plus 2/5 dx. And so that's how I rewrite it in preparation for my integration that's coming. We're going to integrate this side, or find the antiderivative of this side. All right, and let's go ahead and do so. So the antiderivative of cosine is the sine plus a constant, which we're going to move over here and absorb with the other one. And then this over here is raised to the power 1 divided by the raised exponent. So we'll give you 1/5 x to the third plus 2/5 x plus a constant. I need to solve for y. So the best way to solve for y is do the sine inverse of both sides. And so y equals the inverse sine of all of this stuff. And there's your final answer there. Okay, I have a couple more examples down here you can see. Let's go ahead and look at those. Again, separating it out, we can see that's the x and that's the y. So I'm going to divide by the y, so I have a 1 over y dy. And then I'll have an x squared dx. And we're going to integrate both of those. And then each one in its own. So this is a natural log of y again. And this will be x to the third over 3 plus a constant. And so just like before, okay, the previous example that we had before, so this is going to become y equals, after I have y equals e to the x to the third, and I'll put a 1/3 out in front, plus a constant, which we know then is going to become c e to the 1/3 x to the third. And so then the y is going to be plus or minus c e to the 1/3 x to the third. And again, this will get absorbed into the c. If I have a value I can plug in and figure this out, that's what's going to happen there. So this one is a little bit more interesting. Okay, I have to separate the x's and the y, and you can see that they're up in the exponent. But I've already showed you how you can do that split. Remember, this is just simply a 3 e to the 2x times e to the 5y, because you add exponents, and that's what we did up there. So there is the y, and there is my x stuff. So 1 over e to the 5y dy, 3 e to the 2x dx, and then we're going to integrate this, and when I integrate this, I'm going to bring this up to the top as a negative exponent. I want to do all the stuff I need to do to get it set up to integrate. And then here's a 3, which will be out in front. I'm going to integrate e to the 2x dx. Okay? So in these situations over here, we look at this and we say, okay, well, I got to integrate this. Well, this is a u substitution thing. So this right here will be, u is 2x, and so du is 2 dx. And then we move things around. And over here I got another one. So we do them separately. So u would be negative 5y. So du would be a negative 5 dy. And so we'd have to do our u substitution and move things around and then integrate and bring back. To save some time, I'm going to go ahead and give you the answer of what all that would be. It would be a negative 1/5 e to the negative 5y equals 3 over 2 e to the 2x plus a constant. So double check that integration for me, those antiderivatives, to make sure they are correct as we continue on this process. So I would stop right here and I would go and do those on your own to make sure that this is correct. And pause now, and I'll give a couple seconds. Okay, so now I'm back, and we're going to clean this up because we've got to solve for y. We're going to multiply everything by negative 5, and so I'll get e to the negative 5y equals, over here we'll get negative 15 over 2 e to the 2x plus a constant. And then we're going to natural log both sides, and so now I have a negative 5y is the natural log of all this, plus, plus a constant sideways. And then we want to multiply here, so y is now in negative 1/5, this natural log. And that would be your answer right there. Okay? So the next thing we want to look at then, those are the general solutions. So what is this thing called a particular solution? What's the particular solution? It's basically an exact answer. So now we're going to find C. There's an extra step involved. We're going to do everything else exactly the same, but now we're going to do the one where in the slope field you actually found a solution that went through a particular point. We're actually going to find that one now. So this is the separate the variables is what our first step is. We're going to antiderivative both sides. And then once we do that, then we're going to find the value of C using initial conditions. Once we have that, then we continue on and solve for y. So that's what we're going to do. So let's go do that. So here are some more examples that I have for you right here. So I got 3 examples here. This is the first one here with this particular solution right here. Let me move this just a bit so I can go back up here. All right, find the particular solution of the differential equation with the given condition. There's the condition is the 0.17. Here's my differential equation. We want to separate things out, and in doing so, we simply just need to move the dx over to here. So I get dy is 4x dx. And we're going to integrate both of those right there. And in doing so, we get y equals, this would be a 4 times raised to the power 1 divided by the raised to exponent, gives me a 2x squared, plus a constant. Okay, so at this point, we're going to plug in our point, 1, 7. X is 1, y is 7, so I get 7 equals, so I usually do this. So at 1, 7, I get 2, 1 squared plus c. And you work this out and you find out that c is going to be equal to 5. Once you know what c is, you replace the c in your equation so far. And so now I have y equals 2x squared plus 5. And that is a particular solution because I have a y equals already. So let's take a look at this one. Same concept again. Just going to use a different differential equation. We're going to separate the variables. That's the x stuff. This on the bottom is the y stuff. So in the cross multiplication scheme, I now have y dy equals x plus 1 dx. And so I'm going to integrate both sides of those. This over here is going to become y squared over 2. This over here will be x squared over 2 plus x plus a constant. And so usually at this point now we're going to find c. So at this point, which is 0, -2, we plug in. You could have multiplied everything by 2 first if you wanted to. It doesn't matter. So this right here is a -2 squared over 2. This will be 0, over 2 plus 0 plus c, and you find out that c is going to be equal to, as you work this out, you're going to get the number 2. So taking that number and replacing it in here and writing that out, because now we got to get ready and start solving for y. And so now I can multiply everything out, get the fractions out of here. So now I have y squared equals x squared plus 2x plus 4. Okay, and now I have to square root both sides. So now I have y equals, and I'm taking the square root, so I need the plus or minus x squared plus 2x plus 4. And so at this point, which one do I choose? So this is that plus or minus concept that we had before, and this is how you take care of it. You have to look at the initial condition. I'm looking for the one where when x was 0, y is negative 2. So just simply plug in the point again into this and choose the sign that gives you the correct answer. Negative 2 equals some plus or minus a square root of 0 squared plus 2 times 0 plus 4. So this end is plus or minus the square root of 4. So you can see clearly I need the negative value to get a true statement. This means I need the negative value in my answer, and y is equal to a negative square root x squared plus 2x plus 4. And that is your particular solution right there. Okay, continuing on to the next question. This one has trig in it, so thought I'd do this one. So let's take a look at that. Again, we want to separate. Again, I would not take the 4 with the y. I would take it with this one. So I would separate it out as y squared, and then this would be 4 cosine of 2 theta, and that's dy d theta. And so then I can separate it out that way, dividing by that, so I get 1 over y squared dy, and then I'll have 4 cosine of 2 theta d theta. And then I want to integrate this side. I'm going to bring this up as a negative 2. And then this will be a 4 cosine of 2 theta d theta. And so u substitution will have to be used here, and I'll leave that for you to do. If you do that, you're going to get u equals 2 theta, and du is 2 d theta. And then you can continue that on your own and confirm that I'm doing this correctly. So when you get done with that, you're going to end up with this right here. You'll get y minus 1 over negative 1. You're going to end up with 2 sine of 2 theta plus a constant. Okay? So with that, let's continue on here. We have initial conditions. So at the initial point, which is pi over 2, comma 1, y is 1, theta is pi over 2. This right here is going to be a negative, let's see, put my name wrong. So this is going to be a 1 to the negative 1 over negative 1. This is 2 times the sine of 2 times pi over 2 plus a constant. This is just pi, the sine of which is 0. This over here is negative 1, so c is negative 1. And when I know that, I can come over here and plug that stuff in where I was. So, look at this again. You'll see that this is going to be a negative 1 over y, 2 times the sine of 2 theta minus 1. So, look at this as a single object here. Do some cross multiplication and get y equals. You should see and get y equals a negative 1 over 2 times the sine of 2 theta minus 1. And then you can absorb the negative down below, and it could also look like this, 1 minus 2 sine of 2 theta. So it can be either one of those, so just be aware of that. And that would be my answer. Any one of those two answers, whichever choice might be available to you. Okay? Here is another one. Okay? So in this case, we've got to find our y and our x. Our y is going to be y minus 1. See, I cannot separate the negative 1 from that, or the minus 1 from that. And then over here I'll have 1 over x squared. That's my separation. Okay? And so then, moving things around, I'm going to get 1 over y minus 1 dy. And then I'll have 1 over x squared dx. And when I integrate this, okay, this stays here because it is going to be a natural log. And this one over here, when I integrate this one, I'm going to have this one as x to the negative 2 because it's a power. So integrating both of these, I'm going to get natural log y minus 1. This will be x to the negative 1 over negative 1 plus a constant. Our initial point is at 2, 0. So when I do that, I'm going to get the natural log of the absolute value of 0 minus 1. And over here I'll get 2 to the negative 1 over negative 1 plus a constant. And when you work all this out, this is going to become the natural log of a negative 1 in absolute values, which makes it a natural log of 1, which makes this 0. This will be a 0. This over here will be negative 1/2 plus constant. So c is equal to 1/2. So then we go to this one right here, and we write it all out again. So natural log of y minus 1. This right here is a negative 1 over x plus a 1/2. So you want to clean it up some so you can see what you're doing. So then, change form. So now I have y minus 1 e to the negative 1 over x plus 1/2. Okay. Absolute values go with a plus or minus. So now I have y minus 1 equals plus or minus this. And then I can use my condition again, the 2, 0, to determine which one of these signs I need. We can also move the 1 over. And so y is 1 plus or minus e to the negative 1 over x plus 1/2. And so then 0, 1, e, this will be negative 1/2 plus 1/2, so that's 0. So I have 1 plus 1 or 1 minus 1, so the minus wins out. And so y has to equal 1 minus e to the negative 1 over x plus 1/2. And so that would be your final answer right there. Okay, here's an application approach to the same, using the same thing. We have a velocity, v of t is in feet per second, of a skydiver at time t seconds, t greater than 0. After her parachute opens, her velocity satisfies the differential equation dv dt equals negative 2v minus 32, and the initial condition is v at 0 is negative 50. Find an equation for v of t. So I have to separate this out. It's kind of hard. I can't separate things out if there are pluses or minuses. I have to have a product over here, or I use the whole thing over here. So can I do anything like that? dv dt. So look at this and say, can I factor this? And if I can factor it, then I can say, yes, this is a negative 2 times v plus 16. So now I have a product that I can separate if I wanted to. This is the v stuff, and it's going to come over here, and this 2, negative 2, can stay for the dt. So I end up with 1 over v plus 16 dv, and then a negative 2 dt. And then I can integrate both sides there, and I end up with the natural log of v plus 16. And this over here will be negative 2t plus a constant. With our initial conditions, I can then work this out, and I'll get the natural log of negative 50 plus 16. And this is negative 2 times 0 plus c. So c is going to be the natural log of 30, excuse me. This in here is negative 34, but the absolute values make it positive 34, so I can just do that. So the natural log of v plus 16 equals negative 2t plus the natural log of 34. And then we have what? Same thing as before. So we have v plus 16 e to the negative 2t plus the natural log of 34. So v is negative 16 plus or minus e to the negative 2t plus natural log of 34. This thing right here, because it can be split off, can come down here as a positive 34, so this is now negative 16 plus or minus 34 e to the negative 2t. And so which one do I need? So at 0, negative 50, negative 50, negative 16, plus or minus 34, e to the negative 2 times 0, and you can see that I'm going to need the negative, so v is equal to negative 16 minus 34, e to the negative 2t. And there you go. Okay? The next thing here is something we've kind of already briefly talked about, but we're going to look at it a little bit more intently here, and that is the exponential models with differential equations. I think in section 6.2 we talked about varies directly and varies inversely, and so that's what this is looking at again, showing you that if I vary directly, then I get a certain type of answer. And that answer, if you do the differential equation from this, where k is a constant, and you go through this process, you're going to get y equals this plus or minus c e to the kx. And the reason why we talk about this is because if I have a differential equation of this type, where I have some constant times the y, then I don't need to go through the integration to get to this answer, although you can. I can go directly to this answer. And so that's what this illustration over here is showing you. I'm just going to go ahead and show it to you so you can see it and show you the way to look at it also the other way. So if I didn't recognize it, I can just go through the integration process using my initial condition. Look at the question though. If dy dx is 2y and y equals 1 when x is 0, what is the value of x when y is 3? So this implies I have to find an equation for y and plug in 3. And so that's the process we're doing here. We find the differential equation. After we go through the process here of finding the correct formula and stuff, we get y equals e to the 2x. We plug in 3, we solve for x, and we get x has to be 1/2 the natural log of 3. I can do this process. That's not a problem. Okay? This is just showing you that there's an alternate method if you have a certain type of differential equation. Because I have this, and it is of the direct variation format, then we know that k, the solution is going to be this, and we know that k has to be 2. So I can go right to this equation right here. So then I can use my initial condition, and I can find c, okay, and then I can take that, plug in the c, and then I have my value, my equation, that I can then plug in 3 and find the solution for it. So this is just an alternate methodology for showing this, and that's all that's going on there. Okay? And so the next question, the last one down here, is a word problem 1 that you might see. A population y grows according to this differential equation right here, and you can see it's a direct variation, where k is a constant and t is measured in years. If the population doubles every 10 years, then find the value of k. So this could be a question you might see on an AP exam. And so in answering this and recognizing that as a direct variation, so because of that, I know that y equals c e to the kx is the solution to this. I just got to find k to make this happen, and c. So it doubles every 10 years. So what does that mean? So doubling every 10 years gives what? Well, if it doubles, then this is the initial amount, and this is 2 times that amount. So I have 2 times c equals c e to the k, and then that's 10 years. Because we're doing t instead of x. Okay? I should have put a t up in here because it was t as our time frame. So dividing by c on both sides, I now have 2 equals e to the 10k. The natural log of 2 is 10k, and so k is 1/10 the natural log of 2. And if you do a calculator, you will get 0.069. And there you go. Okay? So that ends the video, but what I'm going to do is I'm going to show the notes slowly, page by page. So if you wanted to pause each one and then copy it down if you needed to, you can. So I'm going to do that right now, starting with page number 1. And then here. And then here. Here's those examples worked out with some side notes. And then here's the last one. And the last page. Okay, and so that ends the video, and we'll do more in class.